Online, can you hear me? Can I see the screen?
Yes, sir.
All right.
Yes, sir.
All right, good. All right, so let me start by saying we're doing this thing again tomorrow. The program again tomorrow. 9 to 9. 9 tomorrow. Program, 2 papers again. We do the paper 2, 9 o'clock, same program, and a paper 2. More on the probability than they used to in the past. But tomorrow we're going to cover some of that. It's very important that we're going to look a bit more into the probability. A bit more than just a normal. This number of quantities out of this number of quantities out of a little bit more. I talk about sample space, and I talk about combined probability, independent event, and so on. Right? So I'm going to do some of that tomorrow. In the 2 sessions. The 2 sessions that I'm doing tomorrow, and cover some of that tomorrow twice. First session and also the second. All right. So let us see if we can get through this paper quickly as possible and hear the grades from 6:30. We'll be able to finish this for 9 and get out of here. 2.5 hours, right? All right, let's do this. This is the January 2024 paper, so it's a very recent exam, January last year. So your exam will be very close to this one. The one today was also a good exam to up with the one that we did earlier today. All right, let's go. This question says we have to express this as a single fraction in simplest form. They didn't tell us to use the calculator, but we can still use the calculator to do it. But if you were to show working for this, we'd want to work what is in the bracket first as usual. All right? And when you're dealing with fractions, you want all the fractions to have the same denominator. So if I'm doing this in the bracket here first, I would want this denominator to become 30. So I would multiply this fraction by 2 over 2. And then inside here would become 1 over 30 plus 8 over 30. We are subtracting that from 1. But since we're working with a denominator of 30, it kind of makes sense to change this 1 into 30 over 30 as well. And so it reduces to 30 over 30 minus, and then this inside, you know, works out to be 7 over 30, which then becomes 21 over 30. And then each of these now can be divided by 7. So 7 into this is 3 times, and 7 into 30 is 10. And so that is us. We'll just show some working on this one because it did not say use a calculator. All right, but just to test it with the calculator to make sure it is 1 minus.
Sir.
Yes?
Yeah, I think I worded that wrong, you know. You mean divided by 7.
Right.
You mean divided by 3, not 7. Because 7 can go into 30.
Oh, it's 3. Oh, yeah, that. All right, beautiful.
No problem, sir.
You are sitting in a note. All right. Divided, yeah, what I see it still. This divided by 3, 7. And this divided by 3. All right. I would have seen it in the calculator. That's why I always do a check when I can.
Freezer. You say like freezer.
All right. We have to become 1 over 10. That's correct. Well, after it was 4 to the game, right? We can't use that one. I will get 0.7. So, next question. Come to class, room, let's continue. This question says, Student Park has total of 1,020 parking students. It says at 6:30 hours, at 6 a.m., 6:30 a.m. in the morning, 1:30 of this amount.
Excuse me, sir.
Yeah,
So you're very breaking up, sir.
breaking up.
Yes, sir.
Let me try this one. I get it for. Try again. You get it on your phone. Better? Hello?
Yes, sir.
Yes, sir.
Again, we have 1,020 parking spaces, and at 6:30 in the morning, 1/30 of that parking space is filled. It said during the next hour, more cars left the park, but another 415 of the parking space is filled. Now, if you recognize, these are the same fraction parts that we had in the first one. 130 and 450. All right, same numbers. All right, so 130 over 30 is a fraction of this amount that was there first. Then an additional 450. So that now would basically be representing the sum of these two fractions. That's what that information is representing. All right, so we don't have to do this from scratch. Same numbers that we have. It says, determine the number of parking spaces that is not filled. I want it as a fraction. We don't want it as a fraction. The number of parking spaces that is not filled. Basically, it's the same calculation if you look at it. So this represents like the whole parking space, that one. This one represents the whole parking space, at the portion of the whole parking space. And then you are subtracting the sum of these two fractions of the parking space. That would be the fraction. Yes?
Yeah, change the 7 to a 9.
Huh?
Change the 7 to a 9.
Oh, right, so I'm saying this basically represents the fraction of the information that there is stored. This calculation gave us a final fraction 7 over 10. So you see the 7 over 10 is the fraction of the parking space that is not used. You have to calculate it from that. You understand that? This calculation up here will be the same thing because this inside the bracket represents the total fraction of the parking space that is filled. The fraction that is not filled will be 1 minus this capital. The same calculation we would get to get the fraction of the parking space that is filled. This final figure that we got down here represents the fraction of a parking space that was not filled. If you want to go to scratch, work out 1/30th of this figure, and then work out another 4/15th of that figure, get that total, and then subtract it from this figure, you're gonna end up with the same answer that I'm gonna give you. All right? We have to try and learn and do the mathematics easily. This calculation, I see 1 mark right, so we don't expect a lot of work. So that's 7 out of 10 of the amount 1020. That is the number that we're going to 710 of 1020. 750, 740. Right? If you step by step, we're gonna get the same answer. We put the 130 of it first, and then the 4/15 of it, subtract those two from the whole, and we're gonna end up with this. All right, you can start that way. All right. This one says of the 1,020 parking space, 20% are on the top level. How many parking spaces are on the top level? 20%. 20%. So this is 20% of the total. And that becomes 204. Percentage, 204. 20%. 10% is this. 20% is twice. 204. That's done. Right. Next question. Some of the spaces are reserved for monthly paying customers. The ratio of the reserved spaces to the non-reserved spaces is 5:7. That's the example. The reserved spaces to the non-reserved spaces, 5:7. Total on this ratio is 12. We can extend the ratio to show the total. Total on this ratio is 12. So the fraction reserve will be 5 out of 12, and non-reserve would be 7 out of 12 of the total. Just that says, calculate the number of non-reserve parking. This is 7 out of 12 of the total parking space. 7 out of 12. And what was the total parking space again? This is the total parking space, not just the top entire thing. 1020 here. 1020. That's what we're working. Another one more. This is 7 out of 12. 5. Next question says, cost of parking at a car park shown in the table below. All right. So if you park under 30 minutes, you get it for free. If you park between 30 and 2 hours, you get it for free. If you park between 2 and 4 hours, this is the amount. If you park between 4 and 8 hours, this is the amount, and so on. Right? You see all those. If you park for 1 week, you pay $40. All right, that's a 1 week ticket for $40. It says Michaela is the parking lot at 18:30, and she pays $9.25. So she's paying this amount, $9.25. $9.25 is for parking between 4 and 8 hours. All right. It says determine the earliest time he could have parked the car. The earliest time he could have parked the car must be 8 hours before the time that you left. But understand that? Because remember, enough, for this amount of money, you can park between 4 and 8 hours. So the earliest time she could have gotten there must have been 8 hours before the time she left. This is the amount that she paid. And that's the amount for parking of the 8 hours, but more than 4 hours. So the earliest time she could have gotten there is 8 hours before this time that she left. All right. So basically, that answer is 18:30 minus 8 hours. There must be 10:30 hours. That's 10:30 in the morning. 10:30 hours. You understand that? So with that, for that question. Next question says, Dan Raj bought a weekly ticket for $40. Right? It says that week he visited the car park 5 different times. 5 different times. The length of time he parked his car on each occasion is given below. So these are the length. This is the length of time that he parked on each occasion. These things show that Dan Raj saved $8.50 by paying the weekly amount, by buying the weekly ticket. So what we need to do is work out the total that he would have paid if he was paying for each of these. And the difference between that total amount and the weekly amount must be equal to $8.50. That's what I mean. That's what is happening. So we need to add up the total he would have paid if he was going there, if he was paying each time. Let's write them under it. Let's write them under it in red. So for 25 minutes, I think 25 minutes was free, right? Yeah, because under 30 minutes is free. So this one is $0. We pay $0 for this one, free. 7.5 hours. Let's see, 7.5 hours would be inside here before 8 hours. So you have paid $9.25, $9.25 for this one. Should be $9.25. For 11 hours, that would have been inside here between 8 and 24. So you'd have paid $15 for that time. So this one you would have paid $15. For 8 3/4 hour, which is more than this, that's another $15. 8 3/4 is more than 8 hours. That's another $15 here. And then for 8 hours, you would have paid this exact amount for 8 hours. Another $9.25. $9.25. So the total you would have paid here, I can write it here, this total would have been, let's add it up. It would have been 9.25 plus 15 and the 15 is 30. 30 plus another 9.25. So it would have been $48.50. Remember, I bought the ticket for $40. So you see that you save $8.50. He's gonna save $48.50 minus the 40 that he paid. It was $8. They don't do a lot of space to that's the calculation you have to do. That's the add up the total you would have paid for each time that you park. Then you subtract the amount that you paid for the one. And see that the difference is $8. 3 marks for that one. Everybody got 9 marks on this question. But I get 9 marks. Good. Let's go on to number 2. I don't think I need a calculator. Number 2 wants us to simplify this. So the matter of factorizing the numerator and factorizing the denominator. That's what it is. All right. So the numerator, the common factor is just x. X out of the numerator leaves us with x plus 7. And the denominator under here is the difference of 2 squared. This expression under here can be written as x squared minus 7 squared. And this 49 is 7 squared. The difference of 2 squares now is the difference of the numbers times the sum of the numbers. So it's x minus 7 times x plus 7. And what happens here now is that we have a common factor in the numerator and the denominator. This x plus 7 cancels with x plus 7. And so we are left with x divided by x minus 7 as a simplified form. X divided by x minus 7. And that will simplify my number. What are we going to do that? All right, next one. This one says we have to find R this is equal to x to the r. So all we can do is write this as a single expression. When you multiply indices with the same base, you add the powers. So this side is going to become x to the 2 plus 6. That's what the x to the r is going to be. This 2 plus 6 is 8. So you're going to get x to the 8 power equals x to the r. Since the base is the same, then the power must be the same. So the r must equal 8. So from this, the r must be equal to 8. Just to show some work on it. All right, I could have seen it from right here that the r is equal to 8. Next one. S cubed is equal to 8, and you're trying to find s. So two ways this can be done is if you want to find s, you need to cube root to get rid of that cube. So we can do the cube root of s cubed, clear this cube. Then we also have to do the cube root of 8. You must know that the cube root of 8 is 2. So it means that the s is equal to 2. Another way we could have done it is to recognize that the 8 is actually 2 cubed. And so we'd have s cubed equals, right, this 8 as 2 cubed. So since the power is the same, then this base must equal this base. So we can say therefore s equals 2. So either way the result is the same. S is equal to 2. How many marks for that? 1 mark for that. That's that. Question says, the diagram below shows a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and or B. These are the angles in the triangle. These are the angles in the quadrilateral. What we know about these angles in the triangles that they add up to 180 degrees. What we know about the angles in the quadrilateral is that they add up to 360 degrees. All right. Question says, for the triangle, we have to show that this thing equals 171. Basically, these are the angles. So it's basically using the fact that the total angle is 180. So the sum of these three values is 180. But we can add up the A's and add up the B's separate, right? So if we're adding up the A's, is this and this, that's 2A. We can say, okay, 2A. The total is 180, you know. So we're going to have 2A. If we add up the B's, so it's this and this, those are the B's, that add up to 5B plus 5B. And we add up the numerals. This is the only numeral in there. That's a 9. So add that 9 as well. And that totals, total angle in there is 103 degrees. I'm leaving off the degree, but I said everything was in degree. The equation that they give us is not, we don't have in a degree. So we can take this 9 now and subtract it over here. And 180 minus 9 is 171. So we get the equation that they gave us, which is that 2A plus 5B is 171. That's an easy question. We're doing a similar thing for the quadrilateral. We want to show this. What we know about the quadrilateral like this, these angles that they add up to 180. The same thing again. So adding up these angles and equating that total to 360 degrees. So let's go letter by letter again. Out of the A's, A, that's a minus 2A. So these two make 9A. This and this meant 9A. Then choose 9. That's a minus 2. We have 7A. 9 minus 2 is 7. So the A's add up to 7A. So we have 7A. Then the B's now. B, B, B. Those are the B's. So these two make 6. And another two up here make 8. So that's 8 B's. We're adding 8 B's. And then in terms of the numerals, that's the only number. That's 18. We're adding 18. And that total is 360. All right? That total is 360. And so if you subtract this 18 over here, we end up with what they gave us in this equation. A 7A plus 8B is simply 342. 1 mark for that. But good? Nice and easy. Next one says, solve the pair of simultaneous equations in part 1 and 2 to find the value of A and the value of B, and we're to show all working. So basically solving these two equations simultaneously. These are two simple linear equations, just like they expressed in terms of A and B. We're going to use an elimination method for it, right? So let's write them out here again. So it is 2A plus 5B equals 171. 7A plus 8B equals 342. So in order to use the elimination method, we want the two equations to have the same value on the A or the same value on the B. I'm going to do it this time so that we have the same value on the A. So to make this A, for example, the same value on the A is going to be 14. So the common multiple that's going to bring these two to the same is 14. So to make this one become 14, I'm going to multiply it by 7. So I'm going to multiply this equation by 7. I multiply each value here by the 7. That's going to make this become 14. I'm going to multiply this one by 2. Multiply this equation by 2. So this also becomes 14A. All right? So let me get a calculator to help me. Or you can help me, guys. All right, let's do this. All right. So the first equation here, multiplying this one by 7, it becomes 14A. That's 2 times 7. 5 times 7 is 35. So that's 35B. That's all equal to, we need to multiply this also by 7. So that's 171 times 7. That's 1197. 1197. And this second equation, now we're multiplying it by 2. So multiply this 7A by 2, we get the 14A again. Multiply this 8B by 2, we get 16B. Then multiply this 342 by 2, that becomes 684. So we now have the two equations, and we can subtract them to eliminate the A. So we can do this top one minus the second one. So we can put a line under them here and say subtract. Subtract the two equations to eliminate the A. So this 14A minus this 14A, that is eliminated. Then we have this 35B minus 16B. So we're doing 35 minus 16, that is 19, 19B. Then on the right side, we're doing this number minus this number. So that is 1197 minus 684, and we'll get 513. To find the B, we need to divide by the 19. We can divide this by 19. 513 divided by 19, 27. So the B is equal to 27. We are not done yet. We need to also find the value of A. Find the A, we're going to substitute that B value. Substitute that B value in one of these two equations. All right? Notice they don't give a lot of space to work. So we're going to substitute the B in this equation to find the A. Any one of them we can use, but I'm just going to use that one. Let's do it in purple. So I'm going to sub. Let me just write what to do. I'm just going to write and this equation. Let me write that one beside it, because we're using this equation. And in equation 1, I'm putting the B here. We're going to get 2A plus 5 times the 27 equals 171. But after that, and then now we can subtract this expression and divide by the 2. So we don't have a lot of space. So the A is going to be 171 minus this figure, 2 times 27 is actually 54. And you divide all of that by this 2. And that's going to give us the A value. We work it down step by step, same before. We don't have a lot of space to work with. CSEC, you don't give a lot of space. They expect you to be very efficient with your work. All right, so it is a fraction 171 minus 2 times 27, dividing that by 2. And something is wrong. Because what was this again? No, not much wrong. Because it's angle, right? 58.5. Let me just try it in this second equation if those values work, just to make sure. I want to 7 times the A value, 7 times
5 times 27.
Huh? Oh, it's 5 times. I'm really tired now. This is 5. I am tired. Just never like that figure. All right, let's go again. So it's 171 fraction. 171 minus 5 times 27 divided by 2, 18. Still gonna do the check. Still gonna do the check in this one, just to make sure. So 7 times the A value, which is 18, and plus 8 times the 27, yes, 342. So it's correct. So by checking out what I've discovered that I made a mistake here. That's how it is sometimes. So when you can check, you check. All right, let's continue.
Sir, the 27 for 9 a bracket.
Say that again. Can you repeat that, please? Hello? Somebody talking, I'm here. Oh, this is it for now. Hello, somebody saying something? All right, no. Now let's continue. This question. This question says triangle ABC. AC is 8 and BC is 5. It says using rule and compasses only, construct triangle ABC, and they have already drawn the line AB for us. They have given us the line AB. We need to add AC up here and BC up here. We have to construct it. All right, so let me bring up the device to construct it. Just let's look how this will be constructed. All right. I'm going to draw a line to start with AB. All right, let's draw a random line. Let's say that this is my AB. So you'd have had that on the paper. Right here is A, right here is B. So what it is that we need a line up here now that is 8 centimeters long. And we need a line up here that is 5 centimeters long. To get this 8 centimeter line, because we don't know exactly where it is, we need to get an arc that is 8 centimeters from here. And then we need to get an arc that is 5 centimeters from here. So we need an 8 centimeter arc and a 5 centimeter arc. So let's show it. You want to use the ruler. You want the compass. And we're going to open it up to 8 centimeters. 0. And open it up to 8 centimeters. That's 8 centimeters. Lock it. Move the ruler, and from this end, I am going to draw my 8 centimeter arc. Let's change the color. I'm drawing an 8 centimeter arc up here. So C is somewhere on that arc. Then I need 5 centimeters. I'm bringing back the ruler. I'm going to measure 5 centimeters on this ruler again. Open it up to 5 centimeters. Lock it. Move the ruler out of the way. I will draw another 5 centimeters from B. From B. Rotate up and cross that one. So that intersection point is 5 centimeters from B and 8 centimeters from A. All we need to do now is join them with the ruler, join them with a straight line. And so I'm going to join A to the intersection and join B to the intersection. And that point there is C. So this, we don't know the length of AB, but this is 8 centimeters. This is 5 centimeters. All right. Question says, measure and state angle A, angle BAC. That's the angle inside here, the one. We want us to measure the angle inside here. All right. So to do that, bring a protractor, put the eye on the point, and then you rotate to make sure that your zero pass through the baseline AB. We want to measure on the 0 scale, which is the inner scale. And that looks like the 0 scale takes us up to about 38.5 degrees on this diagram. I don't know what it is on your actual paper, but on this diagram, it is 38.5 degrees. All right. So 8.5 degrees on distance we'll have to use. All right, so that is it. So it will be 38.5 degrees on this drawing that I have. I don't know what it is on the actual paper. So that is the process that we'll have to use to do it. All right, so that finishes that question. One more for that. All right, let's continue over here. All right, so this question now, where are we? Down here. After this question, the diagram below that equilateral triangle. So all three sides are equal. So if this is 13, it means that up here is 13 as well. And up here is 13 as well. Also, with an equilateral triangle, the three angles are equal to 60 degrees. It means that the angle inside here is 60 degrees, 60 degrees, 60 degrees. And if this is the perpendicular height, which it is, then this perpendicular height divides the base and also divides this angle at the top into 30, 30. So this base from here to here is half of 13. So this is actually 13 over 2. And here is also 13 over 2. Why am I doing that? Because the question is asking us to calculate the height h. To calculate the height h, I'm going to focus on one of these right angle triangles. I'm going to focus, for example, on this one. And so on that triangle, I would have this dimension and that hypotenuse. This angle here is 90 degrees, and so I can use Pythagoras' theorem in that triangle to find the height h. All right? That's what I'm going to do. That's one way to do it. I could also work the trig and use a 60 degree as well. All right? I use sine equal opposite over hypotenuse or tan equal opposite over adjacent. So I'm going to work on that purple triangle there. Let's use Pythagoras' theorem first. So what it is that the 8 squared plus the 13 over 2 squared is going to be equal to 13 squared. Pythagoras' theorem. So transpose that and then square root. We would have the h equals the square root of 13 squared minus this 13 over 2 is just what? 6.5, right? So we can put 6.5 squared. 13 over 2 is 6.5. So that's one way to do it. So let's do it another way and see if we get the same answer. Just to make sure. Let's calculate this. This becomes the square root of 13 squared minus 6.5 squared. We get 11.25. Let's call it 11.3. Let's call that 11.3 centimeters. Let's do it another way using trigs. Using trigs, we can work in this triangle again and use sine of 60 degrees because opposite over hypotenuse. We can set sine of 60 degrees equal to opposite h over the hypotenuse, which is 13 in that purple triangle. The h now, we made the subject, we can multiply the 13 over here. So the h will be equal to 13 times the sine of 60 degrees. If this calculation is correct, we're going to get the same as that. So let's do it. So we're doing 13 times the sine of 60. Voila, same thing. So we're getting h again equals 11.3 centimeters. And I gave 3 significant figures, but the answer is not exact. But the question did not say how accurately we must give the answer. If that is the case, we give the answer to 3 significant figures. All right, 2 marks for that one. All right. Very good so far? All right.
Yes, sir.
This question says, the diagram below shows 3 triangles, Q and R. The triangle Q and R are images of triangle P. So this is the original one. Mapping to that. Right? So that double transform. So that double transform. E to R. Right? All right. Question says, describe fully single transformation mapping E onto R. What transformation is one clearly? This and this have the same size, same shape, same orientation, same everything except position. Only the position has changed. I mean, only the position changes. You have a translator. To measure the translation, we need to know how many units left or right and how many units up or down in order to describe it. Only need to see what I'm going. You can use, for example, this point to this point, but these 2 points correspond to each other. So this is 2 units to the right, and then 1, 2, 3, 4 units upwards. It's 2 to the right, 4 up to go from this to this. And so it's a translation given by the matrix 2, 4. Or we can state 2 to the right, 4 units upward. That is the translation. 2 units to the right, 4 units upward. All right. So that is it. Let's describe. Translation. Two units to the right. I could also say given by the matrix 2, 4. So we use this as well. Yeah, man, that's what I just said. If we get this as well. Right. Next one, we're going now from R to Q. From R to Q. We're looking now. We're going from this one to this one. So looking at that one, looks like a reflection. Right? We can check if the reflection because the orientation is to be reversed. So we can, for example, label this one A, B, C in our mind just to check it. Corresponding points will be A, B, C on the image. Orientation on this one is anti-clockwise, A, B, C, and this one is clockwise. So the orientation is reversed. Once orientation is reversed, we have a reflection in a line. The mirror line is going to be halfway between the corresponding points. These 2 points correspond. The mirror line is at the halfway mark right here. So these 2 points correspond. The mirror line passes through the halfway mark. The mirror line passes through those 2. So it is this line, vertical. So when describing a reflection, you state the mirror line, the part of the description. The vertical line passes through x equal to 1. Right here, this line is x equal to 1.
Sir, yeah, break up, sir.
All right, can you hear me?
Yes,
Can you
sir.
hear me?
Yes, sir.
Can you hear me?
Yes, sir.
All right, good. So it's a reflection in the line x equals 1. When you're describing a reflection, you must state the mirror line. You cannot just say it's a reflection. That vertical line has this equation, x equals 1. 9 marks for that question. All right, next question. Question 4. It's a functions question. Don't need a calculator right now. All right. So this is f of x, and that's h of x. This one is 5 to the x. The one f of 4, means you're going to put 4 in the f function right there. So this one simply becomes 2 minus 5 times 4. 5 times 4 is 20. 2 minus 20 is negative 18. That's it. Next one, we want h of 0, means you're going to put 0 in the h function right there where the x is. That's going to become 5 to the power 0. Any number raised to the power 0 is 1. So that answer is 1. Next one. The one f of h of negative 2. So this means we're going to do the h of negative 2 first. So we're going to become f of h of negative 2. We're doing the h of negative 2 first, meaning that we're putting negative 2 in the h function where the x is. So this then becomes f of 5 to the negative 2. And 5 to the negative 2 now means that we need to put 5 negative 2 in the f function. So putting that inside here now. Now we can simplify 5 to the negative 2, but we don't need to do it. Because 5 to the negative 2 is the same as 5 to the negative 2 is the same as 1 over 5 squared, which is the same as 1 over 25. The negative power here means reciprocal. So we can put 1 over 25 here if we want. Put this then as f of 1 over 25. We can or we don't have to. Don't have to do it, but we can do it. All right, so that's 1 over 25. And f of 1 over 25 now means that we put the 1 over 25 in the f function where the x is up here. And by 2 minus 5x. So that's going to become 2 minus 5 times this value, which is 1 over 25. All right, so what is become? This 9 over 5, right? Because this becomes 1 over 5 when you calculate. 5 into this goes 5 times here. And then this 2 is the same as 10 over 5. So like 10 over 5 minus 1 over 5, which becomes 9 over 5. Anyway, you work it out, that is it. 9 over 5. 2 marks for that. All right, next question. They want us to do f to the minus 1 of x. That is f again. Let's make sure we have it. It is 2 minus 5x. So we want to have this. We want to say f equals 2 minus 5x. When we inverse it, some teachers use x and y. That's fine if you want to use x and y. This which is range becomes domain x, 2 minus 5 times. This x becomes range in inverse function, which is f to the minus 1. Then I can make this f to the minus 1 a subject to finish it. Multiple ways to do it. I can take this entire minus 5x, bring it over this side to make it positive. And so I get 5 f to the minus 1 equals, this 2 remains there. And this x comes on this side and become a minus x. Minus x. Then it's a matter of dividing by this 5. And so it will be f to the minus 1 equals 2 minus x over 5. This is f to the minus 1 of x. Okay, I'll put that back in now. That's the answer. Right? If you transpose another way, you might have gotten, would transpose the 2 first, you'd have gotten x minus 2, and you'd have divided the negative 5 over negative 5. So if you get this as the answer, that is correct. Mute the mic, please. All right, so if you got this as the answer, that's correct as well. So it's this or this, right? All right, that is it. 2 marks for that. Next question. It wants us to find f of f. In this form, I will to determine the value of a and b. So to do this, all we need to do is find f of f. Now remember, f of f is the same as f squared of x. So they could have given you x squared meaning the same thing. This is the same thing. So if they give you f squared, it means f of f means f into itself. Let's just write them out and show that process goes. So f of x, remember, is 2 minus 5x, and f of x is 2 minus 5x. This means you're putting f into itself. Same as f squared. Hold on a second. So this here means f into f. So it means you're taking all of this f, and you're bringing it and put it in the f function where the x is. That's how we put f back into itself. And you basically write the construct of that result. So f of x would be this 2 minus this 5 times all of the f bracket. And then we're trying to get it in this format. So this becomes 2 is minus 5 times 2 is minus 10. Minus 5 times minus 5x is plus 25x. So it is minus 8. 2 minus 10 is negative 8 plus 25x. If you compare it to this expression up here, which is a plus bx, you see that the a is minus 8 and the b is 25. So we can write those as our answers now. But that's what the question asks us for the value of a and b. So the a is negative 8 and the b is 25. Those are your answers. What about that? All right. So that's another 3 marks. Done. Moving right along. Statistics, number 5, statistics. Question says, the mass M in kilogram of 120 newborn at a hospital is recorded in the table below. So this must add up to 120, sorry, 120. All right? Hey, you can go home now. You see this going in and out of the class, better not go home. All right? It says state the modal class. The modal class is the one with the highest frequency. This is the highest frequency. And so this is a modal class. All right? The modal class is the one with the highest frequency. So it's this one right here. So it's 4.4 less than the mass, less than or equal to 5.3. I'm going to make sure that I put kilograms on it. The measurement is in kilograms. So I'm going to put kilograms on this. All right? All the data is in kilograms. But go to that, one mark for that one. But okay, one with the highest frequency. Next one says, complete the table below and calculate an estimate of the mean of the 120. They have started it for us. They have put in the midpoint, which we need to represent the groups. When you calculate estimated the mean, the frequency, and they have started the sum column for. Remember, F times X is your sum column. This is your way of summing the mass of all the students, or getting an estimate of the sum of all the students. So we need to complete here and here and here and there. All right? So if you notice, these values are going up by what? 0.9. These values going up by 0.9 as well, the midpoint values. So all the values are increasing by 0.9. The lower limit increasing by 0.9, upper limit increasing by lower 0.9. Well, these are actually boundaries. Increasing by 0.9. So the midpoint values will also increase by 0.9. So to get this value here, we just need to add 0.9 to that. What are we report? 4.85 plus 0.9 is what? 5.75. So this is 5.75. And then we need to add another 0.9 to this. Everything going up by 0.9. What I want to work out to? 7.55. 7.55. Then we need to complete this row by multiplying these two values. So it's this times this gives us this value. And also multiply these two values to get this one over here. All right? Somebody multiply this for me. I multiply these two, what you get?
166.75.
Come again. 166.75. And then this one is what?
60.4.
Huh? 60.4.
0.4, sir.
60.4. That's it. And then we need to add up everything here to get the sum of the X, right? The total sum, the sum of FX. Sum of the sum. That is the estimated sum of the mass of all 120 babies. What does it work out to? Add up all of these now. Anybody? You're adding up all of these figures here now. Okay, if you guys gonna walk in and out of the classroom, I ask you to just go home and leave. Can't get in and out. All right. 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. I'm getting 651.3. Everybody got that? Okay, 651.3. Remember that the sum of your frequency, which is the number of terms, was 120. So that this is the mass of all 120 babies. And so the mean mass is the sum of the mass of all 120 babies approximately divided by the number of babies. That's the mean mass. So the mean becomes 651.3 divided by 120. It's 651.3 divided by 120. That's 5.427 something. So I'm going to write three significant figures. 5.43, and you must say kilograms. All the data is in kilograms. You must say kilograms. All right? But to go to that, 3 marks for that. All right. Next question. It says, probability now. It says, one newborn is chosen at random from the hospital. Remember, you're choosing from 120, right? Find the probability that the newborn has a mass that is greater than 5.3. You want the mass to be greater than 5.3 kilograms. So we need to see how many babies have a mass greater than 5.3. Let's look at the table. Or 5.3. This is 5.3 here. This is where the mass starts to be greater than 5.3 right here. So it's all the babies, all those masses are greater than 5.3. So we're talking about all these babies. 29, 28, and 8 out of the 120. That's total babies whose mass is greater than 5.3. So those are the ones that you want. So take your probability for finding. So it's 28, what's it? 29, 28, and 8, right? Right. So it becomes 29, 28, and 8. That total out of the 120. That gives you the answer. Up here. This is M greater than 5.3 kilograms. All right, let's do this calculation. Fraction 29 plus 28 plus 8 over the 120 as a fraction. That's 13 over 24. Reduce to 13 over 24. That's what it reduces. All right, that is it. All right, very good. This one says now, complete the cumulative frequency table. So they want us to complete the cumulative frequency table. So we need to add up the frequency, right? So let's go up here for the frequency so we can add them up. These frequency values we're adding up. So we write them over here and then copy them. So it was 7, 18, 30, 29, 28, and then 8. Those are the individual frequency values we need to add up. All right, and remember the cumulative frequency column is your counting column. So we have counting the number of babies as a group to group or from interval to interval. All right, so let's look at it now. So if you notice, we started with the 7. So this figure is actually the 7 plus the 18, right? 7 plus the 18. 7 plus 18 is already got that 25. Then no, this 35, this 55, sorry, is this plus this. That gives us this figure. So we need to add this to this now to get this figure. So adding up the frequency, that's 55 plus 29, give us this figure here. We'll put it over here. So the figure for here is the 55, and you're adding 29 to that. So it's 55 plus 29, 84. And then you're adding 28 more. So the 112, 84 plus 28, 112. And then you add the last 8. 112 plus the 8 gives you the 120. So those are the figures right there. That's the cumulative frequency values. And then, anything else? Or I want us to draw the cumulative frequency curve. And I put in a couple points for us already. But this point is wrong. I know that point is wrong. Because the lower boundary value was 2.6, not 2.5. So it was 2.6. So we look back at this, the value before this one will be 2.6, bringing our frequency of 0, not 2.5. So this is 2.6. That's how the frequency of 0, not 2.5. So that 2.5 is wrong. Right? It's not 2.5, it's 2.6. So let's check the scale on this before we start, right? So between here and here is 1 unit, and there are 10 lines. 1 unit divided by 10 lines, each of those is 0.1. Each of these centimeters is 0.1. So this is 2.6. So this value, this point should really be here. That's where it should be. All right, and then the 3.5 cumulative frequency for 3.5 is actually 7. This point is also wrong. If you look at this scale, it is 5 lines in here over interval of 10. So it's 10 divided by 5. Each line is 2. Let's put it here. Each line is 2. So looking for 7. So that's 2, 4, 6, 8. 7 is right here. So this point should be here. That's where it should be. So CSEC does that sometimes. Mistakes. Just like I do. All right. The next point is, let's see if it is correct. Is less than 4.425. 4.425. Let's see if that one is correct. Yes, this is 4.4. And yes, this is 25. So this point is correct. All right. So we're using those points that I'm marking in red. All right. I'm checking each of them and just make sure. The next point is what? The next point is 5.3. Can I write them down? 5.3, 55, 6.2, 84, 7.1, 112, 8.0, 120. So these are the values. These are the coordinates for the points on the graph. Let's copy this down. So we have it on the screen in front of us. Let's put it here. All right. So 5.3 cumulative frequency is 55. So less than or equal to 5.3 cumulative frequency is 55. So based on this, 5.3 will be here. That's 5.3. We're going up to 55. 55 is right in between here. So we're going up on this line to there. So we're talking about this point. The next one. So we just did this one, right? We just did this one. Now we need 6.482. 6.284, sorry. 6.2. So 6, this is 5.5, 5.6, 5.7, 5.8, 5.9. This is 6. What I'm looking for again, 6.2. So this is 6.2 right here. Six point 6.3, 6.4, somewhere around. That's not 6.2. Something is wrong. Make sure I get it right, you know, guys. 5.6, 5.7, 5.8, 5.9, 6, 6.1, 6.2, 6.3, 6.4. All right, good. So this is 6.2. Make sure you get it right. That is 6.2 right there. So coming up on that line for 6.2 for frequency at 84. So 84, this is 80, 82, 84 is on this line. You have to get the graph right. It's on the graph, you have to get it right. And we're coming up on this line for the 62. So we're talking about this point right there. You have to get it right because you're on a graph. Next point is this one. 7.1, 112. 7.1. So this would be 7. 7.1 is here. So 7.1, 112. So coming up on this line for the 7.1. We're looking for 112. So this is 110. So 112 is this line right here. We're going to come up on this line. So we're talking about this point. You have to get the graph right. Because the graph, anything on graph paper, you make sure you get it right. Then the next point, which is the last one, is 8, 120. So the 8 will be right here, and the 120 is right up on that top line. So we're talking about this point at the top right there. So those are the points. Draw a smooth curve through those points, and you have your OG. All right, let's draw it in a different place. Let's draw it in blue. All right, so let's draw a smooth curve through those points. That's the cumulative frequency curve. Something like that. Remember, this graph is at less than or equal to graph. See it? Less than or equal to data was used for it. So this graph is at less than or equal to mass graph. Not just a mass, it's a less than or equal to mass graph. So what would this point mean? They ask what does that mean? 2.60 babies. This point is 2.60 babies. And that less than or equal to mass graph. So it means that no baby had a mass that was less than or equal to 2.6. That's what it means. Right? That's what it means. No baby had a mass that was less than or equal to 2.6 kilograms. That's what. But I can ask, what does this point mean? You can answer that. Remember, right here is 0 babies, and the mass is 2.6, and that's less than or equal to graph. So no baby measured less than or equal to 2.6 kilograms. All right. Question says, use your graph to find an estimate of the median mass. So since there were 120 babies, the median mass is the one in the middle. 68 baby has the median mass approximately. So say 120, half of 120 is 60. So this is the position of the median. Position of Q2, the median. I'm going to read across on the graph. Looks like it's right there. And come down and read that value down here. Looks like it is actually 5.5 is my Q2. So that's 5.5 kilograms. My median mass is 5.5 kilograms based on that graph. Done. Gotta go to that. All right. This time you go and do it over again. Not a comfortable. Go and do it again. All right. Next question. Measurement. Once you say pi, you're now going to be doing some circular measures. Question says, the diagram below shows a hemisphere. Hemisphere is just half of a sphere. So that bowl is half of a sphere and a cylindrical tin. That's a cylindrical tin. It says the diameter of the cylindrical tin is 12 centimeters, but we tend to work in radius. So if this diameter is 12, we're going to work with a radius of 6 centimeters. Let's make a note of it. Half of the diameter is a radius. We tend to work with radius. All right. It says the height is 17 centimeters here. Here is the height, 17 centimeters. And the radius of the bowl is R. So let's call this R different. I want to differentiate them. So this is the radius of the cylinder. This is a sphere. So the radius of the cylinder, let's call it RC. A cylinder. And then the radius of the bowl is R. So we can make a differentiate them. It says show that the volume of the cylindrical tin is this. So the volume of a cylinder is the area of the base times the height. Pi r squared h, but that object is uniform cross section. The formula for the volume of this is also on the formula sheet. So the volume of the cylinder is pi r squared, the radius of the cylinder squared, times the height of the cylinder. That becomes 22/7. That's what they must use for pi. Times the radius is 6, so that's 6 squared, times the height of 17. That calculation is supposed to give you this figure. I'm going to trust that it is correct and put 1923 centimeters cubed. That's what it is. All right, so that's the volume of the cylindrical tin. Question says, The bowl is completely filled with soup. It says when all the soup is poured into the cylinder, into the cylindrical tin, 90% of the volume, 90% of the volume of the tin is filled. So it means that the volume of the bowl is 90% of the volume of the tin. That's what it means. Let's write it out. The volume of the bowl is 90% of the volume of the tin of the cylinder. That's what they basically say. 90% of the volume of the tin is filled. All right, it says calculate the radius of the bowl. Now they give you a formula here. The volume of a sphere is 4/3 pi r cubed. But the hemisphere is half of that. So the volume of the bowl is going to be half of this. So let's divide this 4/2. So it's going to be 2/3 pi r cubed. So that's the volume of the bowl. It's this formula. And that is equal to 90% of the volume of the cylinder, which is this. So setting up this relationship. So the volume of the bowl, which is this, is the hemisphere, 2/3 pi r cubed. That's what's for the radius of the bowl, which is the r. So we're trying to find this r. That is equal to 90% of the volume of the cylinder, 90% of this. 90% of 1922. That's a calculation. And from that calculation, we're trying to find this R. Transpose and find the R. You can do it in one step. You can take this 3, multiply it up here, take this 2, divide it, and also divide the pi. Let's go step by step. Watch this now. I'm going to write it as equal to the 90% times the 1923. We don't have to work out the absolute value yet. Take this 3 and multiply it up here. So it's going to come up here at 3 times. I'm going to take this 2 pi and divide it under here. Divide the 2 pi. That's going to leave us with the r squared, you know. So to get rid of this square, we're going to square root it. So we're going to square root this and drop the r. That's going to give us the answer. But understand that? You want to work towards step by step, that's fine. But that's going to give us the answer. All right? That's the one transposition. If you can transpose, mathematics get easy. Promise you. Transposition is one of the things that gives you problems. Conquer transposition, mathematics get easy. So we're going to do the square root of a fraction that is 3 times 90% of 1923. We're dividing that by 2. And I said the pi must be 22/7. So I'll put that in. This pi is 22/7. So I'll put that down here as well in the calculator. 22/7. 22/7. And get the answer there. And that answer for the radius is not exact, so I'll give it to 3 significant figures. 28.7. Let me shift this over a bit. So I'm writing 28.7. That look kind of big. That look big like something wrong. Something is wrong. Oh, sir, I don't like that answer. That look too big. Huh?
Sir,
Yes.
you wouldn't find the 90% first and then like
No, it's supposed to work out the same. Right? Let me put 0.9 instead of 90% here. And 90% is 0.9. Something is wrong. I'll put this in a bracket under here and see. Oh, sir, something wrong, something all right. This calculator, this calculation going off. It's supposed to work just the same.
Sir, maybe
So
you
the
put the
19,
0.9 times the 1923 in brackets, so
17,
it
20,
doesn't
17,
go by the order.
I change the 90% a while ago. This calculator.
19,
Oh, no,
1923.
sir. I was saying that you put the 0.9 times the 1923 in brackets, because remember that it will go 3 times the 0.9, then
And no
times
matter
the
still, no matter still
1923.
3 times. And no matter still 3 times. Still 3 times.
So try work it piece by piece.
I'm working piece by piece. And that answer is clearly not right. Just that they don't give a lot of speed. Let me work it piece by piece. Yes, in a different column. That answer is clearly not right. And see, maybe we can make a mistake somewhere. All right, so we're going to work 90% of this first, right? So 90%, the volume of the bowl would be 90% of this. Let's work that. 90%. 90% times 9023. So I'm getting 1730.7. All right, and the volume of the bowl, let's write it out, is 2/3 pi r. Oh, I see the mistake. See the mistake. This is a cube, not a square. That's a cube, not a square. So it's supposed to work, man. So that's a cube. Make a mistake and put a square. Cube. So this is actually cube root. That is the mistake. All right, let's go back. So you see, when you're doing a question and the answer don't make no sense, you want to just accept it. Anybody can make mistakes. Finding your mistake is a part of it as well. You have to be able to do that. All right? Anybody can make mistakes. But being able to recognize that the answer don't make no sense and finding the mistake, that's a part of it. All right? Now, the only reason why I'm trying to do it and compress because the space is limited. That's the only reason why I'm trying to compress it. All right? So sometimes I'm going step by step. And I say, but it's cube root of 1, not square root. Cube root of a fraction. You're going to see it work. 3 times 90% times the 9323. And we're dividing that by 2 times the pi, which is 22/7. 9.38. That's much better. 9.38.
Yes, sir, that make it.
Good. 9.38 centimeters. All right, beautiful. All right. All right, that is it. All right, that is it. Let's continue. The next part gives us this diagram. It says in the diagram below, L, M, and N are on the circumference of a semicircle. It's a half of a circle. It's a diameter. You must know that as diameter subtends 90 degrees at the circumference. So this angle here says 90 degrees. All right? This is a right angle triangle, that's a right angle triangle. Another thing is that all these lengths, that length is a radius, that length is a radius, and this length is a radius. And the line from the center to the circumference is a radius. So this is an isosceles triangle, that's an isosceles triangle. So you want to recognize some of those things. Let's see what they say now. So it says the radius is 18 centimeters. So let's put them on. So since the radius is 18 centimeters, this is 18 centimeters. This is 18 centimeters. This radius also is 18 centimeters. All right, and that's a right angle triangle. So we can use so-called tower in it. Pythagoras' theorem. The so-called tower can use Pythagoras' theorem in it. It says, calculate the total area of the shaded section. So the area of the shaded section is the area of the semicircle minus the area of this triangle inside the semicircle. What I say that? Good. All right, that's all we need. So the area shaded equals area of the semicircle, which is half of a circle, minus the area of the triangle inside here. unshaded triangle. So the area of a semicircle is half the area of the circle, which is half pi r squared. So it's half, using pi as 22/7 again on this question. It's for the whole question, must use 22/7, right? 22/7 for the whole question. So it's half of pi times the radius squared. This is pi r squared. Let's put it 22/7 and then write the formula beside it. So it's half times pi, which is 22/7, times the 18 squared. And write the formula beside it. Shift this down and put the formula above it in red. So this is half pi r squared. That's what this is. And then the area of the triangle now is half base times height. And this whole thing is the base, which is 36. And this is the height, 18. All right, so we're going to subtract half the base, which is 36, times the height, which is 18. Using half base times height for the triangle. This we're using half base times height for the triangle. That calculation I'm going to give you the area shade. All right, so we can put all of that in the calculator and do one calculation again. See if you don't give a lot of space to work. You have to work it out piece by piece. Some of you want to tell some of you don't bother come tomorrow and as you're not serious about this. 22/7 times 18 squared, and it was subtracting half again times the base, which is 36. 2 times 18 is 36 times the height, which is 18. 185, 3 significant figures, 185. 185.14 or 185 centimeters squared. It's good enough. That's 3 significant figures. That's what I'm getting, guys. But good at that? But got that?
Yes.
All right, good. All right, beautiful. That question done.
Yes, sir. Yes.
There's another page of the same thing. All right, number 7, the pattern question. This one says, diagram below shows the first 3 shapes in a sequence which forms a pattern. Each shape is made using small white counters and black counters. All right. So these are the black counters, these are the white counters. I just need to observe how they go from shape to shape. So it's like they have this shape inside here. This one is what we had here before. And so they added these counters around it to get the next shape. They added these around it. So that what I'm putting in red is what was added around. So basically, if you look at it then, if you look at it this way. Look at it this way. So if you have this before, is what was there before. You can say they added one to the side, one to the side, one on top, and then added to the side around here as well. All around it, right? All around it. So this is the next shape. We need to do the same thing. So for the black counters, we're going to add to the side on the black counters. Let's zoom upon it. We're going to add to the side of this, 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 add one on top, add to the side of this, add to the side of that, add to the side of that, add to the side of that. So those are the black ones. So I change the color to make it see. I'm going to change the color to blue. So we can see the addition. Let's change the color to blue. Let's change this color to blue so we can see the addition. Good. All right, so let's observe. Anyway, you observe it, everybody's gonna observe it differently. Or we go from shape to shape. Once you get the final thing correctly, good. We're gonna add those white this time, right? So they're going right around the shape again. So you add a one here, one here, one here, one here. Then they're going below. One under here, one here, one here, one there, one there, one there, one there, one there. Then on the side. So that looks like the next shape to me. Do you agree? Good? That is it. Huh?
Understood, sir.
All right, good. So that's figure 4. Yeah, mom, we have to finish that 9 o'clock. Huh? All right, so I should go and build now. So now he's outside of it. I should go and wait. Next question. Says the number of white, W, and the number of black, B, those are the counters, and the total number T that form each shape follow a pattern. So the values of W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table and answer the question that follow. I'm going to complete the rows 1, 2, and 3. So this is row 1, row 2, row 3 is a formula row. Again, we like to complete the formula row first in this class. So let's look at the pattern. Let's observe. So these numbers are these numbers, and they are adding 1. So we do the formula we use start with an n plus 1. Then here you have a 2 times first. These are the n values again. So it's 2 times n. So this is 2n right here. And then you're adding 1 each time. Right? This is 2n. Always 2 times the figure number plus 1. So that's the first formula there. Then over here, this is the n number again. So it's n plus 1 and then the squaring it. So this again is n plus 1 and then it's a square. And then they give us a formula for this over that side. All right? Then I want us to fill out for this row. So for this row, the n is 4. So it becomes 4 plus 1 squared. That's 5 squared. That results 25. And then now, it's a matter of taking this 4 and drop. Everything gone. Everything gone. All right, we're back. We're back, Christopher.
Oh, yes, sir.
All right. All right. So again, this is the total, you know. So you can actually just add up this and this. 45 and 25. How much is that? 70. Let's try
70.
the formula. See. Huh? Let's
Yeah,
try the
man.
formula and see the formula works. Let's try the formula. So it's 3 times 4 squared plus 5 times 4 plus 2. That's supposed to give us 72. So that's 3 times 16 here, so 3 times But that means that the Wi-Fi keep overriding the hotspots. So I might have to disable the Wi-Fi in a minute. All right, let's continue. So for this one, we want the figure number here. This is actually n plus 1. So if this is 144, then it is actually 12 squared. And if it's n plus 1, means that the n is 11. But you can see that over here? N is 11. All right. And then this figure now, we can get this figure by doing this minus this. But remember, the sum of these two must equal that. No, but that's what we'll put in the formula in this one, right? It's a formula. No, it's a formula we're putting in this column. This column must have the formula. And then you put the final figure. So the formula here would be 11 plus 1 into 2 times 11 plus 1. And then we write that what that equals. That will be 23 times 12. 12 times 23, 276. We can check it by doing this minus this. Now these two must add up to that, so we know it's correct, right? 276 plus 144, yeah, 420. That is the table completed, guys. That is it. 1 mark for each value. 1 mark for each value. All right, anything else? Yes. It says the expression for the total number is this. W plus B in shape S is given by this formula. It's the same formula they have here now. Just that the N is equal to S. N is equal to S. It's the same formula. All right. And they have A and B in there. Where A and B are both positive integers. It's by substituting suitable values for S, show that the total number of counters in shape 1 and 3 in terms of A and B are represented by this. So this is kind of easy. You just put in S equals 1 for shape 1 in this formula. And then put in S equals 3. So you put in S equals 1 in this formula, then you're gonna get A times 1 squared. A times 1 squared plus B times 1 plus 2 equals, and what was the number in shape 1? For the total. Total in shape 1 was 10. So put that equals 10. 10 was the total in shape 1. If you subtract this 2 now, you're gonna get A plus B equals 8. Therefore shown. And then for S equals 3, shape 3, and shape 3, when S was equal to 3, the total was 44, right? When S equals 3, the total is 44. So plug in the 3 in this formula again and equate it to 44. So it will be A times 3 squared plus B times 3 plus 2 equals 44. So this becomes 9A. This becomes 3B. Transpose this 2, we get 42. 44 minus 2 is 42. Then to get this equation, now we need to divide this 2 by 3. So we just divide this 2 by 3. We're going to get that equation. 3A plus B, divide this by 3, we get that 7, we get that 40. Divide this by 3, we get 40. That is it. So therefore shown as well. So remember the total in the first shape was 10. So how you do, you put the formula equal 10. Total in the third shape was 44. So you put the formula equals 44, sorry, and then you reduce. And that is it. That finishes that question. Number 8. Number 8 says the diagram below shows a graph of two functions on the same pair of axes. So this is the g function and that is the h function, right? They're just two straight lines. Determine the equation of the g line, the g function, that's this line. To get the equation, we need the gradient and the y-axis intercept. Clearly, the y-axis intercept is 3. So this, we're going to write y equals mx plus c for the equation for that line. Clearly, the c is 3. So the c is equal to 3. What is the gradient? We can use these 2 points to get the gradient. Find the rise of the run between these 2 points. So here's a rise of 3. I see from 0 up to 3, that's a rise of 3. So the rise is 3. And then from -6 to 0, you run across here. So you're running 6. You're running 6. From -6 to 0, you're running 6. So the gradient is 3 over 6, which is a half. 3 over 6 is a half. So the gradient M is the rise over the run. And the rise is 3. Let's shift it out there a bit. The rise is 3 over a run of 6. That's a half. So the equation becomes y equals half x plus 3. What are going to do that? Easy like that. You want to calculate the gradient using those coordinates, fine. But when you see those values, you can count the rise and count the run. That is it. Do it easy, please. All right. Next question is the equation of line H. And based on this diagram, you can see that they are perpendicular. They also said it here, right? The perpendicular lines have negative reciprocal gradient. And also this line passes through this point, which is 4, 0 on x-axis. 4, 0 on x-axis. All right? And because they're perpendicular, they have negative reciprocal gradient. Let's work it out. So we're talking about line H. So line H passes through the point 4, 0. And the gradient of line H is -1 over the gradient of line G. Gradient of line G was half. So you're going to flip this and change the sign. It's going to become -2. Flip the half and change the sign. You get -2. Gradient of this line up here is a half. The negative reciprocal of a half is -2. Flip the half, it becomes 2 over 1. And then change it to negative. So it's that -2 over 1, which is -2. So finding the line with this gradient passing through this point using the BFF formula. Y minus the y value at the point equals the gradient into x minus the x value at the point. Using this formula to get the equation because we have the gradient and a point. So it's y minus the y value at the point is 0. So it's y minus 0. Equal the gradient is this -2 into x minus the x value at the point is 4. And so it's y equals, that's y minus 0 is just y. -2 times x is -2x. -2 times -4 is +8. So that is the answer right there for that line G. Next part says, point P. So we shouldn't call this point P. So I call this point something else because they give us a point P up here. So I'm going to call this point Q down here. Call it something different. So this is point Q. So this is Q instead right here. Q. Same calculation. Don't want to call it P. Right. So this must calculate the coordinates of P. Now clearly, P is the point of intersection of the two lines. So to find the point P, we solve the two equations simultaneously. That's all we need to do to find the point P. Solve the two equations simultaneously. That's this one and the second one down here. All right? So that's what we're going to do. So we're going to say add P. Two equations are valid. Y is equal to half x plus 3 on the first line and y is equal to minus 2x plus 8 on the second line. That's what happens at P. Two equations are valid at P. And so we can put these two things equal, because both of them equal y. Y is equal to both of them. So we can write that half x plus 3 is equal to minus 2x plus 8 at the point of equating the two y values. All right, so the matter of simplifying it. You can get rid of this fraction by multiplying 2 by 2, just need to simplify it. Multiply 2 by 2, get rid of the fraction. Multiply this by 2, we get x. Multiply this by 2, we get 6. Multiply this by 2, we get minus 4x. Multiply this by 2, we get 16. I want to take this minus 4x and bring our add to this x, we're going to get 5x. Take this 6 and bring it over here and subtract from the 16, you're going to get 10. Divide by the 5, we get x equals 2. Everybody can see that? Then the y value is obtained by just simply taking and substitute it back in here, for example. Or if you like, you can substitute it in the first one. And then half of 2 is 1. 1 plus 3 is 4. Anyway, we want to look at it, the y value is going to be 4. You want to show working for the 4, we can put it in this equation. And so the y is half of 2 plus 3 to give us this 4 right there. And so those are my values for x and y. So therefore, P is the point with those coordinates, 2, 4. That's the coordinates of P, 2, 4. But I go to that. All right, beautiful.
Yeah.
All right. Next question. They want us to write this in this form. In other words, they want us to complete the square. This class, remember, the method we use for this is a into x minus xt, t meaning turning point, plus yt. Our xt is minus b over 2a. In this expression, let's write out the a, the b, and the c above it. The a is equal to 4, that's the coefficient of the x squared. The b is equal to negative 24, that's the coefficient of the x. The c is equal to this 31 right here, 31. The xt is minus b over 2a in our formula. Using the h way, then it is b over 2a. What's the difference? So let's work out xt in perfect. So the xt for us is minus b over 2a, which becomes minus the b is negative 24. So it's minus a negative 24. Let me shift this away a little bit. So we're using this. So it's minus a negative 24 divided by 2 times a, the a is 4. This becomes 24 over 8, which is 3. Since this is a whole number, I can find yt by substituting this whole number for the x in the function. That's a quick way to find yt without using the formula method, especially when your xt is a whole number. So the yt value would be just 4 times 3 squared minus 24 times 3 plus 31. That's plugging the 3 in the function to get the y value at the turning point. Word that out with the calculator. Want to use a formula way to do it, then you're going to get the same answer. So the 4 times 3 squared is 4 times 9, which is 36. Minus 24 times 3 plus 31. Getting negative 5 for that. Negative 5. And so the function expression, let's write it in blue. Let's write it in blue. So this expression becomes the a, which is 4. Let me make this a little smaller. I said, CSEC really don't give a lot of space to do these things, you know. So you have to be very efficient. So this is the expression now. The a is 4 into x minus the xt is 3. Don't forget the square on the expression. And the plus yt is negative 5. minus 5. So that in blue is your answer. Anybody got that? Good. Whatever method you use, that's what you must get. Next part says, on the graph below, sketch a graph indicating the coordinates of the minimum or maximum point. It's going to be a minimum, not a maximum. But we know it's a minimum. But the A is positive. When the A is positive, the graph will have a smile shape and a minimum. And the y-axis intercept. The y-axis intercept corresponds to the C value there. It's just a sketch. And the turning point is at these coordinates. 3, -5 is a minimum point. Let's write it. So the minimum point is xt, yt, which is a point 3, -5. Let's put that in a box. They don't give a lot of space to work. All right. So this point 3, -5 is going to be somewhere down here, where the x value is positive and the y value is negative. So the turning point is somewhere down here. And then this y-axis intercept of positive 31 is somewhere up here where the y value is positive. So the graph turns down here and crosses somewhere up here. It's a sketch we're doing, so it doesn't have to be accurate. It crosses somewhere up here at 31 and turns down here at 3, -5. So we'll just need to draw that sketch. Let's draw it in purple, like this. Let's draw it again. Something like that. It's not to scale. Let's take out these blue marks. So you see, I draw a smile that crosses up here and turns down here. It's not to scale. So I'm going to put this as my minimum point, 3, -5. Put this as my y-axis intercept, 0, 31 is that y value, 0c. 0c is a y-axis intercept, 0, 31. That's my sketch. I've shown the minimum point here, and I've shown the y-axis intercept. That's what they wanted. That's a sketch of my function.
Understood, sir.
All right, good. Beautiful. 3 marks for putting on those things. Next question, it says, state the equation of axis of symmetry. Remember, the axis of symmetry is always x equals the x value at the turning point. And if you don't want just to show it, it will be this vertical line passing through the turning point, that vertical line. X equals the x value down here, which is 3. So that equation of axis of symmetry is x equals 3. That is the answer for the axis of symmetry, this equation. X equals 3 is the equation of that vertical red passing through the vertex point. That finishes that question. Next one. Number 9, penultimate question. This question tells us that K, L, M, and N are points on the circumference of a circle, and the center here is O. It says XY is a tangent, that's a tangent. And the angle here is 48. That's the angle between this tangent and this chord is 48 degrees. And then the angle here is 12. That's this angle in between these two lines is 12. And then the angle here is 56. That's the angle between this tangent and this chord is 56. Know right away that this angle is also 56, you know. The angle between a tangent and a chord is equal to the angle subtended by the chord. So this angle here is 56. Before we start, we can see that. Also, since the angle between this tangent and this chord is 48, the chord is going to subtend the same 48 degrees up here at the circumference. So the chord subtends the same angle up here, which is 48 degrees, that it is making with the tangent. Angle between a tangent and a chord equals the angle subtended by the chord. So we know those two angles. We know that this is 56 and this is 48. All right. But let's answer the question. Let's answer the question. Question says, find the value of angle KOL. That's the angle right at the center here. Given a reason for each step of your work. All right. So look at this reasoning now. They want us to find this angle here, right? Now there are multiple ways to do it. That angle is subtended by this chord at the circumference. So if you come back until you reach the circumference to find what is subtending it, that's that chord. All right, that red chord. This red chord. Now that is the same chord that is making an angle of 48 degrees with the tangent. So say the chord subtends the same angle at the circumference of it. So this angle up here is 48 degrees. But the angle between tangent and the chord is equal to the angle subtended by the chord. Now, since this chord is subtending this angle at the circumference, then the same chord subtends twice as much at the center. Angle at center is twice angle at circumference. But I understand that. But we can extend and say that the angle between the tangent and the chord is half the angle subtended by the chord at the center. So therefore, this angle is the same 2 times 48 degrees. So we can extend the rule that way as well. All right, so it's 2 times 48, because it's 2 times the angle up here. Angle at center is twice. So anyway, take it. That angle, KOL, is 2 times 48 degrees. 2 times 48 is 96 degrees. I want to write out reason like this. Angle between tangent and the chord is half the angle at the center subtended by the chord. Angle between tangent and chord is half the angle at the center subtended by the chord. So basically shorten the rule. So as I said, what you could do is go step by step and do a 2-step process. You could have said, okay, since the angle between this and this is 48, then the angle up here is also 48. And since the angle of the circumference is 48, the angle of the center is twice that. So it's 2 times 48. So that is a reason as well you could approach it that way. In any case, the angle here is 48 degrees. It's 96, sorry. The angle at the center here is 96 degrees. That's the first angle, 96 degrees. All right, next one. And that's not the only way to do it, right? There's never one way to do it. So that's the reason, 98 degrees. Next one says, find the value of each of the following angles, and then don't ask us to write any reason. Or one person asks for a reason. So you cannot calculate, right? So it's a find angle of each. So angle LMN, let's look at it. LMN, where is that? Angle LMN. LMN. That's the sum of these two angles. See that? So we can actually populate this diagram for them, you know, and do it. So see that this angle is 48 degrees. We just did that a while ago. But it matches the angle between the tangent and the chord right here. So this angle is 48 degrees. Let's write it on the diagram. So this angle inside this is 48 degrees. And they will say that because the angle between this chord and this tangent is 56, then this chord is subtending the same 56 degrees here. So this angle inside here is 56. And therefore, the angle that they want, which is all of this, L to M to N, is the sum of those two, 56 plus 40. Everybody can answer that?
56 plus 40.
Yes, sir. You can see it.
Good. So this angle is 56 plus 48. 56 plus 48. What I work out to? 104 degrees. I said I don't put any line for you to put any reason, right? Just wanted to calculate it. Next angle I want is KLO. KLO. Let's look where that angle is. KLO. Angle KLO. That's this angle right here, the one. That kind of easy. Because this triangle is an isosceles triangle. Why is it isosceles? Because this is the radius and this is the radius. So it means then that these two base angles are equal. And since you know this one already, both of them equal, you can 180 minus the 96 divided by 2 to get this one here that the one. Everybody see that? Good? Because that's an isosceles triangle. And they're asking us for this one, which is also equal to this one. So this one is 180 degrees minus that 96 degrees and you divide that by 2. So it becomes 90 minus 48. All right? Just write it down here. So it becomes 180, and that's the only way to do it. Remember, it's never one way to do it. 180 degrees minus the 96 degrees at the center and divide that by 2. So it becomes 90 degrees minus 48 degrees, which is how much? 42? 42 degrees. What about that? So that angle is 42 degrees right here. Let's put on the diagram. I define it, put on the diagram. I might need it to find something else. So this angle right here is 42 degrees. And all of this is 42 as well, don't it? So if all of this is 42, and up here so it's 12, means that right here is 30 degrees, right here. 30 degrees. Because the total is 42 and right here is 12. 42 minus 12 is 30. Let's write this better. So this is 42 degrees as well, part of the isosceles triangle. So right there is 30. All right, I'm just putting it on the diagram. What I'm going to do they want next? They want MLK. Let's see where that angle is. MLK. Angle MLK. MLK. So they want all of this angle now. So to find all of this angle now, we can work in this triangle now that is in blue. Up here says 48, down here says 30. So this angle over here that I want is going to be 180 minus the sum of those two. I'm doing it this way that jumps out at me right away. So this purple angle that I want becomes 180 degrees minus the 48 and the 30. Total angle of that triangle is 180. So that's 180 degrees minus that's 78 degrees. How much is that? What's that add up to? Minus 71st and then minus that's what? 102? 102 degrees. 102 degrees. There might be other ways to do it, but that's the way I'm using now. Let me just copy this down. All right. 102 degrees. That is it. That's because total angle in the triangle, I'm putting it here. 102. And then the last angle that they want down here, each of these is just one marking. They want angle K and M. Let's see where that is. K and M. So K and M now. Let's mark it in red. K to N to M. So now they want this angle over here. So let me erase some of these things and show you when I get this angle now. I will just work out this 102. I'm going to use the 102 to get it. So what it is now, we mark it in purple. They want this angle. This angle is one of the angles in this cyclic quadrilateral. These two opposite angles must add up to 180 degrees. Those two opposite angles must add up to 180 degrees. And so that's going to be 180 minus 102, which is 78. Let me show you another reason why that is 78. right away. Let me show you another reason why it is 78. So we're saying this angle over here is 78, right? This angle is 78 because it's 180 degrees minus the 102. Because of these two angles are opposite angles in a cyclic quadrilateral. But I'm going to show you another nice way why it is 78. Watch this now. Another nice way why it is 78. So that angle up here, to come back till you reach the circumference, here and there. That angle up there is subtended by this chord that I'm marking out in, let me mark it out in blue. That angle up there is subtended by this chord that I'm marking out in blue. That chord is making an angle with this tangent. What angle is it making with the tangent? This total angle across it. So it means that the chord is going to subtend that same total angle. What's that total angle? 48 plus 30, which is 78. So anyway you look at it, this angle is 78 degrees. Good? So whichever way you want to look at it, it is 78 degrees. Let's just use the 180 minus 102. So maybe that's what they wanted. 180 degrees minus 102, that is 78 degrees.
Could I use right angle too?
Huh?
How many say could I use right angle too?
Right angle?
Yeah, the 90-degree one. Right at the 56. Yes, in connect to the center.
Right. Yeah, man. All right. All right, good. There's always multiple ways to do them. Always multiple ways to do them. Always. All right. I think that finishes that question. I'm supposed to have a bearings question now. All right, good. Here we go. Question says, E, F, G, and H are 4 points on level ground. Diagram below gives information on the distances and angles between the points. So everything is on the diagram, right? These are your meters, and these are your angles. All right, those two. Question says, show that the value of X is 29.5 to 1 decimal place. Show that that angle is 29.5 degrees, 1 decimal place. So to show that the angle is 29.5, you calculate it, or you would normally calculate it. So to calculate this angle, we're going to be working in this triangle. It is not a right angle triangle. So we have to use sine rule or cosine rule in it. When you have a triangle with only 3 sides, they don't know any angle, you have to use cosine rule. So to use cosine rule, we need to establish our 2 sides and angle between. And then this side over here is like the opposite to the angle. Remember, start like Pythagoras' theorem. So this starts out like as if it is an hypotenuse. Good? And then this is the angle between them. So using the cosine rule, I'm going to transpose to find the x. That's what we're going to have to do. So it's going to be that this side opposite the angle squared, 6.9 squared. Using cosine rule. Using cosine rule. Start like Pythagoras' theorem. So this side across from the angle squared, 6.9 squared, is equal to the sum of the square of the other 2 sides. That's the 5.3 squared and the 11 squared. So that's what it would be if it was Pythagoras' theorem, but it's not Pythagoras' theorem. So you have to subtract a piece. You subtract twice the product of the 2 sides here, 5.3 and the 11. I do the cosine of an angle between them, which is x. So now what it is, you have to transpose to find this x. All right, I'm going to do it in one step and show it. I don't have a lot of space, or give a lot of space. All right. So I'm going to take all of this. I'm not going to bother to work them out piece by piece, because that's waste of time. I'm going to make one transposition and do one calculation. I'm going to take all of this negative expression, bring it over this side and make it positive. Take the 6.9 squared, bring it over this side and make it negative. All right? So all of this is coming over this side and becoming positive. So I'm going to write 2, 5.3, 11 cos x equals, this stays 5.3 squared plus 11 squared. And then this now goes over and is subtracted. Minus 6.9 squared. Now I can take all of this and divide it under here. That's one of the reasons I encourage students to do the work in pencil in the exam, believe it or not. So I would erase this and just put it under here now if I'm in the exam room. So I actually encourage students to do the work in pencil with a clean erase. Right? So all of this is going to be divided under here. All of this is going to be divided under here. Like that. And then to make x a subject, we're going to do cos to the minus 1 of that. So let me shift it around again. And put the equal here. So I'm going to take the inverse of cos. I'm going to take cos to the minus 1 over here. Leave x as a subject. So I'm erasing the cos. I'm putting cos to the minus 1 of this entire thing. We get x. But understand that? But good? Online? Online good?
Yes, sir.
That's why I encourage pencil. They can erase some stuff and move them around sometimes. So just put this in the calculator, now you have the x. And I know it's going to be 29.5 degrees. But let's move it to the calculator. Let's just make the calculator show it for you. It worked? You tried it a while ago? Yep. Yeah, me know, but me don't know. You go one step like me. I go step by step. All right, so I want to see my one step work. So it's cos to the minus 1 for fraction 5.3 squared plus 11 squared minus 6.9 squared. And you're putting that over 2 times 5.3 times 11. See there, 29.5 to 1 decimal place. Sure, beautiful. That is it. All right? That is it. You see, they don't give a lot of space, guys. Sometimes they don't have a lot of space on the paper to be writing whole heap of steps. So they learn to be efficient, all right? Learn to be efficient. Let's continue. So the angle is 29.5. So know that the x in here is 29.5. Let's put on the diagram. So this x is 29.5 degrees inside here. Let's squeeze it in there. 29.5 degrees. That angle, right? That's the x. All right, what does this say now? The next part says, a vertical tower GT is constructed at the point G and is pivoted to the ground at the points E, F, and H using pieces of wire. All right? It says the angle of elevation of the top of the tower T from F is 31 degrees. All right. Let me see if we can give a visual of what they basically say. So it's basically like they put a tower, a vertical tower at G right here, right? And this is the top of the tower. And then you have these points on the ground around it, right? These points on the ground. One at the back. So these are all points on the ground. So you have F out here, you have E up here, and you have H behind it. And then now they use wires now from this vertical pole down to these points. So this is actually a right angle triangle. These are all right angle triangles. But this vertical and this horizontal. Right? But we only need to see one of them. We only need to see one of them. Based on information. It's from F to G. So the vertical thing is that G, I would do it a vertical down to F. And angle of elevation is this. So let's see what I said again. So a vertical power is placed at G in the middle, and the top of it is T, and the angle of elevation from F somewhere out here is 31 degrees, and right here is 90 degrees because the angle between vertical and horizontal is 90 degrees. And the angle of elevation, angle looking up to the top of the tower up here, angle of elevation looking up there. This angle is 31 degrees looking up. That's the angle of elevation looking up. What is this distance on the diagram? GF. GF on the diagram, remember now, is 6.9. So GF, this distance on the ground is 6.9 meters. That's the elevation view for that situation. All right, and the question is asking us for the length of the wire. It says, what length of wire connects up here? So it's T to F. So we want to find the length of that wire. So because we want the hypotenuse, that's the hypotenuse now in that right angle triangle, and that's the adjacent. This is adjacent to this angle. So I want to use cos. Cos is adjacent to the hypotenuse. So I want to say the cos of the 31 degrees equal the adjacent of 6.9 over the hypotenuse, which is TF that we're trying to find, TF. To make TF a subject, we're going to take the TF and multiply it up here, take the cos 31 and divide it under here. So we're going to end up with TF as a subject equals 6.9 over the cos of 31 degrees. So that's what we're working on for TF. 6.9 what? 6.9 over the cos of 31. What you get? 8.05 meters. Because they're giving it to three significant figures when the answer is not exact. Beautiful. Next part now says the bearing of E from H is 228 degrees. We have to put on the diagram so we can see what does that mean. Remember, bearing is measured at the from position. So it's from H to E. The bearing is 228. Let's put it on the diagram so we can see what is happening. From H to E is 228. From H to E. So from H down to E, the bearing is 228 degrees. So at the from position H, we want to show the north line, which is already there. And this is the line that we measure on the bearing down to E. This is a clockwise angle around here. That is 228 degrees. That clockwise angle is 228 degrees. But I go to that, based on what they said, that angle is 228 degrees. Remember, this is the part of it is 29.5, you know, inside here. It's 29.5. Let's see what they want us to find. So put that with 228 on the diagram so we can see it. They want the bearing of H from E. So they want now from E to H. We're going to put that angle on the diagram and see what it is. From E to H. Let's look at it now. From E to H, they want the bearing. From E to H. So they want the bearing from here back up to there. So the bearing that they want is this one. From this point E back up to H. So the angle that they're talking about is this angle right here. But I give it that, that's the angle that they want. So that angle and this angle add up to 180. Why? Because these two lines are parallel north lines. They are connected with this line down here. So these are what we call co-interior angles. They add up to 180 degrees. That's not the only way to do it, but I'm going to do it this way today. The question is, what is this angle in here? This angle in here is 360 minus this. But the total angle around here would have been 360. We know up to here is 228. So inside here is 360 degrees minus 228. As I said, this is not the only way to do it. I'm seeing another way to do it right now. How much? That's 132. So this is 132 degrees. And then because these two add up to 180, it means that this bearing angle that they want is 180 minus 132. 180 degrees minus 132 degrees is that bearing angle that they want, which is how much? 48 degrees. But we have to put the 0 in front because it is bearings. And we can leave these calculations on the diagram. It's okay to leave those calculations on the diagram. And then show it down here that the bearing is that 0.48 degrees equals 0.48 degrees on the diagram. Did the calculation on the diagram. So you look at the diagram to see the working. Then they want the bearing of G from H. Let's mark it again. Always know the from position, guys. It's from H to G now, they want the bearing. Let's see what that angle that is. From H to G. Let's see what angle that is on the diagram. From H to G. So it's from here. Look what they want. From here down to here. So they basically now want this angle that I'm marking in purple. But they want it down to this G. So I'm marking that angle now in purple that they want. So we're trying to find this purple angle now. So that purple angle is kind of easy. So remember, everything around here is 228, and this 52 is a part of that 228. So this angle, purple angle in here that I want, which is bearing angle, becomes 228 degrees minus the 54 degrees. What I work out to?
174.
How much?
174.
What is your report? I'm not hearing the person. I'm not hearing.
174, sir.
Yeah, 174 degrees. All right, I'm not hearing what you were saying. All right, 174. All right, and then we're gonna write 174 and say workings on the diagram again. So I'm leaving these markings on my diagram to show I get my calculation. All right. So this angle here now is equal to 174 degrees. And again, check the diagram, please. I'm telling the examiner to look at the diagram to see how I got my 174. All right, so that is it. Question done. One question left. Matrices, transformation, there, vectors. So this one starts out with a vectors. Starts out with a vectors question. All right, let's see. Question says, in the diagram below, O is the origin right here. And OE is 2 times EF. I like to put these on my diagram so I can see the ratio of the line. So this OE has 2 EFs on it. And this EF is just 1 EF. So basically the line is in the ratio 2 to 1. So it's 2 parts, 1 part, so the total part is 3. So this becomes 2/3 of the whole line. And this is 1/3 of the whole line. But can I appreciate that? 2/3, right? So this is 2 parts, then write it, and this is 1 part. All right, those are the parts. So this is 2/3 of the whole thing, this is 1/3 of the whole thing. What did they say now? They say M is the midpoint of this line. Okay, so this is the middle of that line. They said OG is C. So this vector out here is C. Let's put it on there. This vector out here is C. This is vector C. Put on in red. Let's put on the vectors in red. So this vector here is C. And this vector OF is D. So watch this now. I'm going to put the parts. Remember, the whole thing is D, you know. So this is 2/3 of D, and this is 1/3 of D. I'm going to put on the parts. So this was 2 parts out of 3. So this is 2/3 of the D up to here. And then here is 1/3 of the D. But I can appreciate that. The more information you put on the diagram, the better. And you want to see how you go around from point to point. That's what the vectors is at this level. Just how you go from point to point, going around the diagram. Question now says we must calculate the vector FG. FG. So, because we have the 2 position vectors, we can find FG easily by doing O times the last minus O times the first. So this is OG minus OF. The OG is C minus the OF is D. That is it. C minus D. Or we could say it this way. To go from F to G, we could come down here, which is a minus D, and then go across here, which is a plus C. Same thing, C minus D. The diagram shows that. All right. Next part says, EG, E to G, same thing again. We know that OG is that. Again, OE is this, and OG is C. So because we have the two portion vector, we can use that again. It's O times the last, which is OG, minus O times the first, which is OE. Last minus first. O times the last minus O times the first. So the OG again is C minus the OE is 2/3 D. So it was a good thing to break it up. 2/3 D. That is it. Next part wants OM. M is the midpoint of this line. So we can use the midpoint formula, just like we use in coordinate geometry. The average of the position vectors of the endpoint. So OM, because it is the midpoint of EG, it becomes half of OE, plus OG. Average the portion vectors of the endpoints. So it becomes half of the OE is 2/3 D, and the OG is still the C. That's not the only way to do it, but it's a good enough way. So doing half of this and half of that. So this becomes 1/3 D, half of 2/3 is 1/3, plus half of C. Now, if you're not confident about the answer, if you're not sure, you can actually check it. This is saying to go from O to M, we must go 1/3 D and half of C. We can check it now. 1/3 in the direction of D and half in the direction of C. Let's check it, if it makes sense. We go from O to M. What did we say? 1/3 D plus half C. So what is now? This is a whole D. 1/3 D gonna take us to about here, so. That's 1/3 D. Remember, this was 2/3 D, you know, so 1/3 D is to here. And then we need a half C. See there? Half of a C. A whole C is this, you know. This is about half of a C. And this is about 1/3 D. It takes us from O to M. So we can confidently say that that answer is correct. All right? So that's why you can double check your answer with the diagram. Your calculation and your diagram must always match. And when you're not sure, you can check it out on your diagram. All right, let's continue. All right, done. That's it. Done. This is the answer for you. Nothing else. That is it. Then we'll come to the matrices. This question says PQ and R. Matrices PQ and R are given below in terms of scalar constants A, B, and C. So this have a A in it that we don't know. This have a B that we don't know. This have a C that we don't know. It says, given that P plus Q is equal to R, meaning that when you add these two, it equals this one. So this plus this is equal to that one. That's what the basically say. So, for example, this plus this is equal to that. All right? Add the corresponding values. This plus this is equal to that. And this plus this is equal to that. P plus Q is equal to R. So let's do it. So to get the C, it is this plus this equals C. So it is 3 and minus 1 equal to C. That is 2. So the C equals 2. So 2 equals C. We're going to do them on the right answer when we're done. Then this and this equals that. So it is A minus 4 equals minus 4. So clearly the A equals 0. Then the next one, the B now, it is this and this that is equal to that. So that's the minus 9 and the B equal minus 3. So this 9 goes over here, becomes a positive 9. 9 minus 3 is 6. So the B equals 6. Let's write them on in order. So the answer is A equals 0, B equals 6, C equals 2. What about that? Online, everybody okay with that?
Yes, sir.
Nice and easy. Next one. It says solve this pure simultaneous equation using a matrices method. A matrix method. So to use a matrices method or a matrix method, we have to first write the equation in a matrix form. So we have x followed by y, the first one, which is good, x followed by y, the second one, which is good. So this becomes a 2 by 2 matrix times a column matrix xy equals a column matrix 44, 10. Then the coefficients up here go in that matrix. So it's 5 and negative 2 on the first line, 2 and 3 on the second line. That's the matrix equation that was solved. So we need to take the inverse of this matrix in front of this to leave xy as a subject. So the xy is going to be the inverse of this matrix, the 5 minus 2, 2, 3 to the minus 1. I'm putting the minus 1 on it in the red so you can see it. Multiply that now by the 44, 10. So the inverse of this matrix comes in front there when we transpose it. So we need to calculate the inverse of that matrix there, which is 1 over the determinant times the adjoint. So we do over that space and we make this smaller and zoom in. All right. So we calculate the inverse of this matrix here now. So the xy comes equal to, how do we get the inverse? It's 1 over the determinant. Remember, a matrix to the minus 1, the inverse is 1 over the determinant of the matrix times the adjoint of the matrix. Now, what's the determinant coming under here? Is this product, the leading diagonal product, minus the trailing diagonal product. So this product is 15. 5 times 3 is 15. Minus, this product is negative 4. Negative 4. This becomes a minus minus a plus. That actually becomes 19 under here. So multiplying that now by the adjoint matrix. How is that form? Interchange these two elements on the first diagonal. Switch them around. So you switch them around to 3, 5. Then leave these two where they are and change the sign. So change this one to a 2. Change this one to a negative 2. Note, I did not switch them around. Looks like I switched them around, but I did not switch them around, these two. I left them where they are and changed the sign. They multiply. This now is just the inverse here. No, don't underline it in red or in purple. This matrix, the inverse, is all of this that we just worked out. Multiplying that by the 44, 10. Then what we're going to do, we're going to multiply these two and leave the fraction out here for last, the 1 over 19. It's going to become 1 over 19, all right, 16, times a column matrix, which is the product of these two. So to multiply those two, multiply the rows of this matrix with the one column, and the result is going to give us 2 values. So how do we multiply these two matrices now? This first value is in the first row and the one column. So to get it, we're going to multiply this first row by this first column. You multiply them first element times first element, second element times second element. First element in the row by the first element in the column, second element in the row by the second element in the column. So it's 3 times 44 and 2 times 10. 3 times 44 is how much?
132.
132 and 2 times 10 is 20. So you're adding 20 to that. We'll move this bracket a bit. Then the second value here is positioned in the second row and the one column. So to get that value, we're going to multiply this second row by that one column. Same way again. First element times first element, second element times second element. First element times first element, second element times second element. Minus 2 times 44 and 5 times 10. Minus 2 times 44 is negative 88. 5 times 10 is 50. Let me continue down here. Don't worry, that's space. This reduces to 1 over 19 into, what does it work out to? 152. And this works out to
negative
38. So dividing each of these now by the 19. So 152 divided by 19 is how much? 152 divided by 19 is how much?
8.
And negative 30 divided by 19 is negative 2. So that's xy equals that. Remember, this is not your answer. You have to explicitly state the x and the y. So your answers are x equals 8, x equals 8, and y equals negative 2. These are your answers, not the matrix. Just finish when you state the value of x and state the value of y. End of this test. And that is that. All right, guys, we're going to go, and I need to know how much you're going to get. Add up on the marks and tell me, what is this? Add up your marks and tell me. Anybody who be in the mark, don't come back, you know. Oh, let me hear how much you're going to get. Pass mark is 80%. Add up your marks and tell me how much I got. When I see a mark, you can go. Remember, do the same thing again tomorrow, guys. I look, you know, give me some discipline tomorrow now. That's what you get. Good. Come on, get the go and redo the question that they got wrong. Redo the question that they got wrong. I want to see 85% tomorrow. Okay, so you need to finish, because you need to finish in the exam. So, no, but you have to practice and do the time management. Do the time management, I will tell you, you have to finish the exam to maximize the marks. All right, so work over the 17 marks wrong. We get wrong. Watch your video over and read it. All right, go on. Look over the 19 you get wrong. So say you never die. I'm proud of you. Once again. See it there? So you wouldn't know if it is over. Go and look over the 24 you get wrong. And make sure you come tomorrow. Once again, I go on. When you finish one paper at a time. Once again. All right, good. Remember, guys, anything you get wrong, work it over for me, please. You don't know what's coming on the exam paper. Anything you got wrong, work it over for me, please. So I'm going to see you guys tomorrow. When you come tomorrow, come with discipline for me now, please. Yes, sir. Come with discipline, please. Yes, I want to check it. How much you get faster? Come on, how much you get? Come in. Oh, don't show me it's already. What you get? What you get? Show me it's already. Yes, sir. Huh? All right, we're doing 2 new papers tomorrow, guys. I'm going to do some probability work tomorrow as well. So 9 a.m., same program. Tomorrow, same program like today, we're doing tomorrow. And maybe next weekend again, we'll do the same thing. Next weekend, we'll do the same thing again next weekend. More maths equals better maths. And this is how you stay. Jaden. Carissa, where you get? A person I want to show you. Jaden, where you get? Send me a message. Send me a message where you get. You don't want to talk. Let me know how much I got. Pass mark is 80%. Young lady, where you going? Oh, all right, good. Work over the 27 marks, please. Work them over. All right, guys. I'm gonna end it now. Nobody's saying anything. We're gonna do this again tomorrow. The video of this is online. So you can just go on the channel. My channel is my name, Rafik A. Shaw. If you want the link to it, you can send me a WhatsApp. And I send the link to you so you can watch over anything you want to look back at. All right, guys, I'm going to end it now. We'll be doing it again tomorrow. 9 a.m. Start at 9 a.m. Same program. 2 papers, 1 paper in the morning and 1 paper in the afternoon. We're working on 4 papers again. I'm going to spend a little bit of time tomorrow on probability. All right, because CSEC setting some relatively new stuff. The structure is probably a little bit different in recent times. So I'll spend a little bit of time talking about that tomorrow as well on both papers. I'm going to do it in the first session and do it again in the second session tomorrow. Talk about power. So see you guys tomorrow. Bye, everybody.